Extra minute. The very last extra minute.
Nice. Nice.
The biggest comeback.
Yeah.
That's awesome. You were watching it together?
Yeah.
Where'd you watch it?
Bleeding Horse Club.
Great.
Yeah.
And big TV?
Big TV.
Nice. Everybody excited?
Everybody was. They almost kicked us out.
Nice. Nice. Oh yeah, field, isn't it? Yeah.
Can you change them?
Yeah, I'll fix it now. No homework, are you sure? Oh, I started the second lesson. We're in the middle of doing it, isn't it? That was it, yeah. All good?
Yeah. I remember also.
Oh yeah, so I don't forget. Diaz and Mir, we have a double class now. You were supposed to have Isabel at 10 o'clock. So instead you're having me now, and you'll have Isabel later when you should have had me. In other words, me and Isabel have swapped for today. So we have a double now and then. Yeah.
But we don't have Isabel today. Like, individual.
I don't know, whatever. Whenever you had me later today, instead you have whoever you were supposed to have at 10. You just swap. Okay, where did we finish last time? Oh yes, we did the 4 diagrams.
Yeah.
Okay. Equipotential refers to the region in space where every point in it has the same potential energy. So I'll explain with pictures in a moment, but this is the definition of equipotential. Has anyone got a scrap piece of paper, or like just an old piece of paper, or tissue? Yeah. Yeah. No. I don't.
Tissues there?
Yeah, tissue's good. I have bad news. Someone has requested a test, so I'm going to give you a test next week. But I also understand you have a lot of coursework to do as well. So I don't know. I wanted to give you a maths test on what we've done in maths so far in semester 2. Would anyone have huge objections to doing that next week? You would object to doing it next week, meaning you don't want to do it next week. Okay. Any other?
You can do AAP assignment, chemistry assignment, math assignment, chemistry.
What about Musharif? What about if I give you the test and then it's your choice if you give it to me to correct or not? You would be okay with this then? Okay. The reason is because I want to give you an opportunity to convince me I can give you a higher predicted grade. So like for example, Musharif, if you felt like you wanted to give it to me afterwards, and if you get a result that's higher than what I predicted for you, then I have a good reason to give you a higher predicted grade in maths. So, we'll do it next week. What day will be best next week then? In what class?
Friday?
Do we have?
We don't have math on Friday.
Well, we have physics. It doesn't matter. We can swap subjects. When is your assignment due? Next Friday?
So math next Monday.
Yeah.
That's the only one that's due next week, but we have to work on it.
You have to work on others.
Yeah.
Then do you want to do it earlier in the week to get it done? So you're not distracted by it?
Okay, what I think is,
Yeah.
the whole idea of the test is good for me because it gives me a reason to actually revise what we have.
Yeah.
So I really don't, I'm neutral.
Neutral, okay. Musharif, any preferred day? Same neutral. Mir, you preferred Friday.
It's fine.
Well, they're neutral, so it doesn't really matter what Adnan thinks because
No, he's fine.
you're speaking on behalf of Adnan.
Yeah.
Friday next week, we have a double class, but I only need to give you 1 hour for the test. what I'm planning on doing is, the final test is 2 hours long, so I want to give you a half final test. Just a half of the things we've done so far, so I'll cut out half the questions. So we'll do it on Friday then. Yeah. Okay, good. Now, did you write that down? Do you remember potential energy in semester 1? Yeah? So, let me show you what I mean by equipotential lines. What's the formula for potential energy? mgh. So, if this is at a height of 1, and for this example, the mass is 1 to make it easy, so the m is 1, okay? If this is at a height of 1 meter, and this one's at a height of 1 meter, their potential energies are the same. Agreed?
Yeah.
And here that 1 meter is the same. So everywhere on this 1 meter line is the same potential energy.
But the mass doesn't exist.
Oh, yeah, the mass is 1. It's like this. If I have a mass m at height h, and I move it over here, mass m of height h, it's the same potential energy. So if this is the ground, if the mass is anywhere on this line, it has the same potential energy. Now, if it's on this line, it has a different potential energy, bigger or smaller? Bigger, but everywhere on the line is the same potential energy. So, of course, these are different, but everywhere on the line is the same. So, all these lines are called equipotential lines, because everywhere on the line has the same potential as everywhere else on the line. So, if the m is here or here, it's the same. If it's here, it's different, but if it's here or here or here, it's the same. These are equipotential lines. That's what I mean. Now, we have to draw the equipotential lines for the charge particle. Can I scroll down? Okay. So, think about this. If I have a mass here, and I let go, it falls to the ground. What energy does it have on the ground when it hits the ground? Kinetic. Where did this energy came from? It had potential here. Yes? Now, imagine the ground is positive charge. Let's say we're in space. There's no gravity. We're floating around. The ground is positive, and this electron is negative. If I let go of the electron, what will happen? It will fall to the ground. What energy will it have when it hits the proton on the ground? It has kinetic. So that kinetic must came from a potential as well. So it also has a potential energy. So if, for example, if this is a positive charge, or, well, let's put the negative in the middle, and if this is a positive charge here, everywhere on this line has the same potential, because it's all the same distance away from the negative charge. Everywhere on this line, same potential. Different than the previous, but everywhere on the line is the same. So these are the equipotential lines for the charged particles. So this fella here and this guy here, they have the same potential energy, and then they will move in. So if I just put this one here and put this one here and let go, they'll move to the center. They'll have kinetic energy at the center, which will be the same as the potential energy they had on the outside. Yeah. Okay. They like asking students to draw this in the exam for like 1 mark. They say draw the equipotential lines around a negative charge or a positive charge. No, just the lines actually. So for the exam, they say draw it around a negative charge, so they want to see a minus, and then this. That's it, yeah. It's only 1 mark, you know. Okay, continue. So now, hang on, why is my little colour still there? So I drew these. Oh yeah, so I'll draw them into 4 diagrams actually. So you can see everything in the exam. What was the first one I gave you? Point, which I've done. The second one I gave you? Okay. Next one? Aha. We'll say positive here, negative here, or it doesn't really matter. And then the last one is a dipole, like a positive and a negative. So here we've seen this one. And again, this one, it's also the same. This one here, do you want to have a guess at what the potential lines might be?
They will be like this.
Yeah, just like this. And then this one's a bit hard. Actually, this one's quite hard because these ones here will go around. But if I put a particle here in the middle, it doesn't have potential energy because it's not going to move. So I can't remember how to draw this one. I think I have to kind of go like this nearly. Yeah, that's it. Yeah, it's hard for me to draw. But they don't. There's no potential here, so they don't connect in the middle. So it's the kind of this sort of shape to them. Yeah. It's interesting because in the exam they only have in the past asked students to draw these three. Now that doesn't mean they won't ask for this one, but all the examples for the last 9 years have been just the three, not the fourth one. But if you can add these to your notes, it'll be good to have. Be strong, Sharif. Be strong. Have you studied this before? New topic?
No, not all, but
Equipotential.
we didn't study potential for the dipoles.
No?
We did it for the point charge.
Okay. Yeah. Just a point. Can I continue? Yes, continue. Okay. Next. So, how do you make an electric field between the two parallel plates? So if you want to make a point charge, you just need something like a proton or an electron. If you want to make a spherical charge, you just need lots of protons or lots of electrons. If you want to make a dipole, you would need like a proton and an electron. But how do we make the field for the electric plates? Well, you make it quite simply actually. If you have two parallel plates and you connect them up to a high voltage cell, then what will happen is the current travels through the air between the plates and makes the field here. Now, it works better if you have a vacuum, meaning there's nothing blocking it, and it's important that they don't touch, but this is how you make an electric field. Okay. So when a current is passed through two conducting plates, that's the key, and the distance is d, and the voltage is V, then the electric field strength is a different formula. Last time we did the electric field strength is F over Q. However, we can't really do that one here because, well, I mean we could do that one here, but we have another formula if we know the V and the D, which is convenient. and it's quite simple as well. Then the electric field is produced with a strength of just V over D. So this is quite a convenient formula because it means you don't need to know the force and the charge to know the electric field strength. You just need to know the voltage, which is very easy to know, and the distance. Yeah, so that's a key formula, very important for this lesson. For this chapter, actually.
This is a definition of...
No, I suppose it's really just a formula. And what is the electric field strength when you pass a current through two parallel plates? Okay, you got that? Where? Did you write this down?
Yes.
All of it?
Yes.
Great. What mobile phone do you use? What company? You're Meteor. You have the same deal as me, €10 deal. Yeah. And you're on...
Free.
And you're on... I found a new company which my wife signed up to, and I think I'll sign up to too. Have you ever heard of Lycra Mobile? Lycra Mobile?
Yeah.
And what do you think?
It's good in England, I think. They have good.
I live in Germany, I don't know how about it here.
But I
Seemed
have heard
okay
that.
yesterday. Yeah?
I've heard that here, like,
How
most of the people at Meteor, this.
I'm thinking of switching because they have a really, really, really good deal. For €9,
Yeah.
you get 300 text messages, 300 minutes, and 1 gigabyte data.
Data is that.
No, but that's for the cheapest package. So like for like €15, maybe you get like 10 gigabytes. But then for like €20, you get something like
Unlimited.
30 gigabytes. No, it's never unlimited. It's never ever unlimited. When the phone company says it's unlimited, it's not. If you read the small print, it will have some limit in it, like 20 gigabytes or something.
But my internet, like, it's 24/7 open.
Yeah.
I
But
always
my point is, if you use it too much, they will tell you. For example, Meteor said it's unlimited, but when I looked at the website, they said unlimited, subject to fair usage of 8 gigabytes. So, unfortunately, in the UK and Ireland, I think it's quite unfair and maybe should be illegal. But in the UK and Ireland, when internet companies say unlimited, it never means unlimited. Never. It's good. It's important that you know that, because you don't want to get a letter saying we have to charge you because you've used it too much.
I have like a mobile SIM at home. Someone gave me like it's new.
Yeah.
I can use it.
I might switch. I'll tell you how I get on. But €9 sounds like a good deal to me, you know. Okay, next now. Come on. Right, so when you have a point charge, we have a formula for calculating the electric field strength as well. So you have a point charge here, and we'll say its charge is Q. And what do you think we'll need to know in the formula? We'll need to know the distance we are from Q. Will the electric field get stronger or weaker? What do you think? If you move further away, if the ore is increased, will the electric field get stronger or weaker? Weaker. So, it won't maybe surprise you to learn that the formula for an electric field strength when you have a charge Q, no, you're not too far off, it's Q over R squared. This here is just a constant, okay? Now, often, this constant here is quite messy to write, so a lot of times, including in your formula book, this is just written as K for constant, which I think is on your calculator.
The same as dV equals.
No, not the same as this K. It's a different constant. Can I have a look here? So you have this constant here. So if you type in 1 over 4 pi epsilon, it's the same as the capital K, but I don't think you have the capital K constant here.
It's the small k.
No, that's a different constant. Yeah. In the formula book,
32.
you have this. Can you type in that constant on the calculator so we can write it down?
Just the constant itself.
I mean 1 over 4 pi epsilon 0.
Okay.
Let's see what I get. So,
How do I break the epsilon?
it's on the lid. Shift 7 and whatever the number is for epsilon 0.
It's a huge one.
Yeah, it should be. What is it? Something like 8.99?
There's no point here. It's just one big number.
Can you hit the button to change it into a scientific form?
Just say,
What
just
is it?
say.
What's the...
SD button maybe?
No, nothing. It's not the whole number.
Nothing.
Oh,
8, 9, 8, 7, 5, 5, 1, 2,
yeah. It's 8.99 times.
Yes, this value is like this, something like this. 10 minus 10,
10 to
7.
the 11,
10 to the 9 then. Yeah. Yeah, so it's a big constant. And we have to work out what the units are, which we'll do now in a second. So we know the electric field strength, the formula is this constant times Q over R squared. Let's work out the units for the constant. So you have E R squared over Q equals K. So what's the unit for E? Very good, newtons per coulomb. The R squared is meter squared and the Q is coulomb. So it's Newton meter squared per coulomb squared. Yeah, Newton meter squared per coulomb squared. That's the constant. You don't need to know this. It's on, this is in your calculator, but this one here also is in the formula book for the exam. You need to know the formula. This is the strength. As Iad was saying, if the R is bigger, then the field is weaker, but it's not Q over R as you thought. It's actually Q over R squared, which means it gets weaker quicker as you move away. At a distance R. Epsilon 0 is just a constant. Now this is the value for epsilon 0. I don't even want you to write that down because the only time you need it is for these formulas. It's on the calculator, it's in the formula book. And anyways, I would prefer you to use the K because then you're typing less. You're not typing in the 4 pi epsilon 0. You're just typing in a K here. Yeah, K Q over R squared. Let's see what the units are, which we've just done. Okay, so the formula, please note that.
But R square is going, is at the bottom.
Yeah, so if the R is big, the strength is small.
But we have to find in the units of what? E.
No, K.
Okay, then
Oh yeah, here I was saying like the E, but I did it for the K. Actually, the units I mean the same except just upside down. Okay, do you have the formula?
Are these all formulas for electric field strength?
Yeah, just different for different situations. So when you have parallel plates causing the electric field, it's V over D. When it's a point that's causing the field, it's this. Continue? Right, so here is our first example. You have two horizontal plates with a voltage of 200 and they're 1 centimetre apart. And the positives on the top and the negatives on the bottom. How long would it take half a milligram of charged 10 to the 10 electrons? Oh no, sorry, I have to be careful with my signs. 10 to the 10 E. E is a positive on the calculator, isn't it? So I meant protons here. To fall from the top to the bottom. Yeah, because if the top is positive and the bottom is negative, it will be pushed away. You know, if you put a positive by the positive plate on the top, it will be pushed down to the negative plate.
Yeah.
So, let me just draw what we have and then we'll work on it together. We have two plates. This plate has a positive charge, this plate has a negative charge, and there's a field here. So when you have a small positive charge, it will want to move down. The charge here is 10 to the 10 E, so 10 to the 10 protons, positive charges. It has a mass of half a milligram, which is 0.5, and milli is, my goodness, how much of a kilogram? -6, thank you, of a kilogram. What else do I tell you? The voltage here is 200 volts, and the distance is 1 centimeter. How long for it to take to travel from the top to the bottom? Okay, so first piece of business, it will feel a force. What forces will it feel? First, a force from being in the electric field, but also another force. There's two forces acting on it. What's the second force? It's a very, very small force. The weight, yeah. But because the mass is so small, it's tiny compared to the other force. So F equals the force from the field plus the weight. You know the formula for F. You have this formula, E equals F over Q. So F equals QE, and the W is mg. Do we know the Q? Yes. Do we know the M? Yes. And the G? Yes. And the E? No, but we could know it because the formula, which formula should I use for E here? Yeah, V over D plus mg. And what's the formula for F from Newton? Ma. So we get G plus QV over dm is the formula for the acceleration. And then it just becomes a UVATS problem. U is 0, V we don't know, A is whatever number this is, and S is 0.01. And I'll take down as positive and up as negative. Yes, Mr. Sharif? The M, I divide everything by M. So M is cancelled, M is cancelled, M is under.
Direct.
Yeah. Direct, yeah. Let's calculate the acceleration here. Oh, I don't have my calculator open yet. Maybe you're typing it in?
Yeah.
Do you have your calculator? Can you type it in to confirm? So it's this term here I want you to type in. And the D is 0.01. The Q is 1010E. The V is 200. I'm thinking it should be a pretty big number.
On the U and A.
Yeah, and they're working out the A.
But I think you need to simplify.
Yeah, U, S, and A. They're getting the A. This is for A. Yeah? Are you sure? Sure. Let's see what, yeah, I guess.
10 to the 10 E. That's
Yeah.
constant 23, right?
Yeah.
Oh.
10 to the 10 E times 200 over 0.01 times 0.5 times 10 to the 9.
Here, I have the calculator open now.
23.8 times
What's the D? 0.01 and the M 0.5.
3.9. Yeah.
And then the Q and the constant is, you said 23?
Yeah.
And the V is 200.
Yes.
Oh, okay. Not as ginormous as I thought, but pretty big. 73.9 meters per second squared. So what will give me, what was I looking for? The T, wasn't it? So what formula would best give me the T here?
That's what
S equals to half a UT plus.
S equals UT plus a half AT squared, maybe? What do you think?
Yeah.
So the U is 0, so the T would be 2S divided by A square root. Square root fraction 2 times 0.01 over the A, which we just have previously. So it should be a small time because the acceleration is quite large, so like milliseconds. No, actually not as small as I thought, but if I just put it into milliseconds, 16 milliseconds. So the final answer here milliseconds. What do you think? This one's okay? I make it look easy, don't I? Okay, continue? Yes or no?
That's fine.
Okay. You have a big breakfast, Musharif?
Mm-hmm.
You have lots of energy. You're the fastest one today.
No, I didn't have.
But how come you write so quickly today? What's the secret?
I wrote when you were silent. T.
Okay, continue?
Yeah.
Right. This one here. An electron is 2 millimeters from 3 protons. What is the force? So an electron is 2 millimeters from 3 protons. What do we say 3 protons were? Like lithium or something?
Yeah.
So you have 3 protons, and there's an electron here, and the distance is 2 millimeters. And I want to know what is the force here. Right, so what's the formula for force here? If we remember, E is F over Q. What's F?
EQ.
EQ. We know the Q, 3 protons or 1 electron? Which is it?
What
One
else?
electron.
Very good. And what formula could we use for the E? No, because they're not parallel plates. It's the other one.
1 over 4 pi.
Yeah, the K Q
Over r squared.
over r squared times Q. Now, to be clear, I should maybe call this one Q E for electron. But this Q is for the proton because it's the protons that are making the electric field. So this one here is from the protons, and this one here is from or for the electron. So in other words, it's K charge. Where's this now? I think I know who this is.
Bring the vegetable and make video.
I was expecting to call after lunch. I'm not ready for their call. I'll just let it ring away. No, well, there's a reason. I'll explain why. Oh, good. They stopped. Good. No, what happened was yesterday we were looking at houses. So yesterday one person said, "Do you want this house? It's this much." And I said, "I'll think about it and I'll let you know tomorrow." But then we saw another house in the evening and we said, no, we'll go for this one. So we gave them the money for that house. So I'm just waiting for those people to confirm that everything is okay and they have the money and all that before I tell the other guy we're not interested. So I was hoping he'd call after lunch because I haven't received an email from the people yet, so I'm not ready to talk to him, and he's not going to be watching these videos, so unlikely, highly unlikely. Yeah. Okay, so as I was saying, Q proton, Q electron over R squared. We know the K, we know this one, we know this one, and we know this one, so everything should be okay. What was the K value I gave you? 8.99
by 10 to the power
10 to the 9, wasn't it?
Yeah.
And then this is 3 protons. Oh, I won't worry about the sign, okay? 3 protons. Oh man, I can't avoid it now. He's calling me twice. Hello? Yeah. Oh, I got it. Thanks for calling. I've got a minute there, yeah.
Have you seen the thing for the back? Why? Well,
That's the whole. Have you ever watched Life of Pi?
yeah. Nice, so nice. Man, like, Life of Pi is like no like fighting, nothing, like it's just slowly.
Where is she from?
You danke,
She's not very famous.
gracias,
Obrigado.
hola,
That's it.
pasivo, gracias, no, danke. Man, there is no problem. It should be. No, oh yeah, shukran, jamila, ittihadun. Man, it's racing.
Like in full relationship, right? He wants to break up with the old one, but he doesn't want to tell her because he knows
Thank you. It wasn't, it was the bank. Okay, 3 electrons and then, 3 protons and then 1 electron.
What is it? I don't know. Do you know? Oh, it's just the charge.
Oh yeah, the charge, yeah.
What about the proton?
It's the same. It's the same E. You notice proton is the same as electron, just an opposite sign, but the number value is the same. All over, which is okay the way I typed it. Yeah. In this case, in this one you can, because they're the same. 4q squared. But in some cases they're not. It's just because these are protons and electrons, which are the same. And what's the or? 2 millimeters squared. So you get this tiny force. Although the force is tiny, because the mass of the electron is tiny, it kind of is actually. This actually is, although this is tiny, it's quite big for the electron, because what's the mass of an electron? It's like 10 to the minus 31 or something? Roughly, something like this, isn't it? 27. So although this is a small number, if you were the electron, it would feel very big for you, because you're only 10 to the minus 27, and this is 10 to the minus 22. What? Who? Write the name down. From September? Okay. I see. You're the only students I have from September, actually, now that Roland has swapped math classes with me. So I thought you might be shocked to learn how quickly teachers forget students' names. So I'm like, who?
No, it's alright.
But some students' names are more difficult to forget than others. You know, it'll take me a while to forget about Hisham. Amin as well. Who else will take a while? Maybe Abdullah as well. It'll take a while to forget. Okay.
Wow, so those who leave a bad impression.
No, that's not true. The good ones do. It's just the bad ones take longer to forget. Oh, wait, they're probably thinking they have a class here at 10 because were you all together for like Isabel? I'll let them know. Hi guys, you think you have problems? But that class is swap. Yeah, I just know I'm in here for physics, so you're not in here. Unless you want to do physics, of course you're not. We had to do this swap like a couple of weeks ago.
The class is on D201.
Yeah, and just this week.
It's just
because of last week and this week. So it's just for these weeks. But it's back to normal next week then. Okay, alright, see you.
So they must be having class in D302.
Yeah, that's what they taught downstairs, yeah. Is this question okay, guys? Hey. Is this question okay? Yeah. Okay. Yeah. No, relax.
Can we summary for number C?
No. Oh, summary. You want me to...
Harder than some.
Hang on. Be strong.